2.1. Somewhere in here. Okay, radical functions. All right. So our focus on this, on 2.1, is just on the square root function itself. Okay, so it's the one graph that, one of those 5 graphs that we already know, and that is you go through 0, 0, 1, 1, 4, 2, 9, 3, 16, 4, and so on. The base of the radical function y equals square root x has the following graph and properties. Its x-intercept is 0, its y-intercept is 0. The domain to begin with is x is greater than or equal to 0. The range is y is greater than or equal to 0. The intercepts in domain and range suggest an endpoint of 0 and 0 and no right endpoint. The graph is shaped like a half parabola. The domain and range indicate that the half parabola is in the first quadrant. The base radical expression or function is y equals square root x. Okay, so again, I mentioned this to you before. We're using the same principles all the way through this course for graphing. Your A, your B, your H, and your K, they all are used over and over again. So if my first graph is y equals f of x, then my g of x graph, my general one, can be represented by A. Actually, hold on a second. Okay, A square root. Now, here's the catch in the whole thing. You can't have a value directly in front of that x. All right, so we have to make sure that we factor it out at all times. So it looks like this: b x minus h plus k. Okay, so that b value has to go in front, but not directly in front of it. Okay. Vertical stretch by a factor of absolute value a. If a is less than 0, the graph is reflected in the x-axis. Okay, I don't think I need to describe all of this. We've already done more than enough of this in the first section. So let's look at filling in the blanks on page 40. Okay. All right. Explain how to transform the graph of y equals absolute x to obtain the following graph. Y equals -2 square root 4, x subtract 3, add 1, sketch the graph, and so on. Okay, so what is the a value in that graph? -2, resulting in a compression or stretch? Stretch by a factor of 2. Yeah, I because it's an absolute value, so I stretch by a positive value. But the next part here, since a is negative, the graph is reflected in the over the x-axis. That's right. Okay, so keep filling in your blanks there as we go through this. What is b? 4, which results in a stretch by a factor of 1/4. H is no 3 plus 3, right? It's opposite. So the graph is translated direction right by 3 units. K is plus 1. So the graph is translated up by, yeah, very good. Okay. So if I were to graph it, and what I would do is I would start, I like this idea behind this. Now I didn't show you this near enough, I don't think in that first section, but let's do it right now anyways. And let's see how this works. Alright, so my original, I'm going to pick 4 coordinates. We agree? Those are the 4 coordinates on the original one. Square root of 0 is 0, square root of 1, square root of 4, and square root of 9. Right? So those are my original. Now, we always do the stretches first. So let's start with the 4 in front of the f of x. So what am I doing to my graph? What am I doing here to the coordinates? I'm stretching it, but what am I doing to the coordinate with that 4? Which, yeah, which is represents what? Yeah, which value of the coordinate, x or y? Y. Y. F of x is y, correct?
Oh, yeah.
Right? So, what am I doing here? I'm multiplying my y values by 4. So now, okay, so anyways, I'll do it this way. So this is still 0 and 0. 1, 4, 4, 8, correct? 9, 12. You agree? Yeah? Okay. The next is the b value. So that's a 4. So that's like, so now I've got 4 f of 4x, like that. So what do I do to the x values?
Divide.
Divide all my x values by 4, correct? So it becomes 0, 0, still, 1 quarter and 4, 1 and 8, 9 over 4, and 12. So far, so good? Okay. Now I go what am I doing to my coordinate now?
What x subtract, or x plus 2.
Add 3 to all my x values, correct? So 3 and 0, 3 and a quarter, and 4, 4 and 8. What is that? 2 and a quarter, so that's 5 and a quarter, and 12. Are we following this so far?
This makes more sense.
Okay, and now what am I doing to my coordinate now?
Adding 1 to
Very good. And then I would graph that. Okay? Now, I have a mistake. What was my mistake?
2.
Yeah. -2 actually. Right?
Yeah, I was wondering that. I was like,
Nobody else say anything, so you just kept quiet?
yeah, I was like, okay.
Yeah. This should have actually been -2 right here. Correct? So I'd have to go back and do that all again. Now, here's the thing. Let's ignore what I have in the book, because we've done all this work. All right? Looking at this right now, what's my domain for this graph?
this is such that.
It's not gonna equal 0.
Pardon me?
It's not gonna equal 0.
No.
X is greater than or equal to 3.
Yeah. Yeah, very good. My domain for this graph is x is greater than or equal to 3. Because I moved, for this one was 0 and 0, right? But I moved it 3 to the right. So that graph is going to actually look like that, 3 to the right. Okay, so then if it looks like this, what's my range for this graph?
Y is greater than or equal to 1.
To which? 13, right here, right? Oh, no, sorry, my bad. 1. Tough day already. Why is it not on the reels? Understand that? Okay. What do you suppose the domain is? Does the domain change for the graph if I put that -2 instead of a 4? Does it affect the x's at all?
No, because you're just multiplying your y's.
Exactly. So what would be my range for that graph then? Zach? What's the range for the graph? For the graph on the actual page there.
Can it be -1? Y is greater than or equal to -1.
Last time. Because that graph's actually going to flip over the x-axis, right?
Oh, yeah.
And open down.
Yeah.
So, okay, so we kind of totally ruined it. Actually, I understand why I did it now, because I looked at example 2. Okay, let's do example 2 together. Okay? We'll do the exact same thing that we did here. They kind of do their chart horizontally. So, let's go through this whole thing. A is what? 4, which is a,
Right.
which one, vertical or horizontal?
Here.
So,
No.
so it's vertical.
Yes.
Yes, you're correct. So a vertical stretch by a factor of
Or
4. What's B?
-2.
Results in a stretch, a horizontal stretch by a factor of,
-half.
yep, and a reflection in the, over the
Axis.
y-axis,
Or,
right? Because it's directly in front of the x. So we're changing our x values. H is,
-3.
results in a horizontal translation of 3 units to the left. Good. K is -5, which results in a vertical translation 5 units down. Okay, we catching on to this? All right, and like I said, we're going to consistently go through this the same way for every graph that we do in this course. Yeah.
How do we know 4 is a vertical stretch? Like with A.
Because it's A.
Because it's your A value.
Okay, so it's
It's
always
in-
gonna be vertical.
Well, it's always in front of the f of x. It's in front of the whole equation.
Mhm.
So, okay, so that's a good question. All right, let's go back to the graph that we know best. Y equals x squared. What happens when I put a value that's not 1 in front of it? What happens to it?
It the slope changes, or kind of.
Okay, we don't use the term slope
Yeah.
on parabola, right? So the width changes. You agree with me?
Yeah.
Goes up faster, so it goes up narrower, correct?
Mhm.
Which means that you've changed all your vertical values because you multiplied them by the original equation. So you times all your original y values by 3, correct?
Yep.
Same reason for this. If your a value is 4, you're multiplying all of your values, your y values by 4. All right, let's fill this chart in now, okay? So we have 0, 0, 1, 1, 4, 4, 2, and 9, 3. Same starting one. Okay. What does the vertical stretch do to each of these? 0 and 0 becomes what? 1 and 1 becomes? 1 and 4. 9 and 3 becomes? Very good. Horizontal stretch. 0, 0 stays as 0, 0, correct? So now I've got 1. I better write this out because I can't visualize this. Alright, so f of x is equal to. So I've got 0, 0, 1, 1, 2. Okay, so the value in front, the a value was 4, correct?
Yeah.
So this time I got it right. 0, 0, 1, 4, 4, 8, 9, 12. All right. B value. Is that. Okay, so now stays at 0 and 0. Agreed? All right. 1 and 4 becomes what?
And 0. Or 4, sorry.
Very good. That's really good. Okay. 4 and 8 becomes, Zach?
What?
What does 4 and 8 become?
4 and 8. 2 and 8. Negative 2 and 8.
Negative 2 and 8. Right? 9 and 12.
Not too sure.
What are you doing to your x values here?
You're dividing by 2.
We're timesing them by negative a half. You agree?
Yeah.
What's 9 times negative a half?
That would be negative 4.5 or 9, 2.
Okay. So far so good. What's my h value?
Plus 3.
What does that do?
Use it left.
Left 3. So this becomes
Negative 3. Or, yeah, negative 3 and 0.
good. This guy.
Negative 3 and a half. Or no, 3 and a half.
Oh, you're right first time. Yeah, negative 3.5, right?
Yeah, and 0.
This becomes negative 5 and 8. And then this is
Negative 3 and negative 2. Yeah.
okay. And then last,
That's your K value, which is negative 5.
negative 5.
Yeah.
All right. So what does my first one become? Negative 3,
Negative 5.
negative 5. There's my starting point. Negative 3.5 and
Negative 1.
negative 1. Negative 5 and
3.
3. Negative 7.5 and
Negative 7. Or 7.
how's that for you?
Makes more sense.
Makes more sense?
That happened last year.
Okay. All right. Okay, I'm just going to show you 2, 2. I'll show you 2, 2, and then you guys can, we got to get that test finished and whatever else. All right, so what we did here is we took the square root of x as a function in itself. Now what we're going to do is we're going to take the square root of an actual function. Okay? So I'm going to graph y equals f of x. Could be anything. And then I'm going to take the square root of it. So the square root of f of x. To graph the square root of f of x, you can set up a table of values for the graph y equals f of x, and take the square root of the elements in the range, while keeping the elements in the domain the same. Alright, so that's the important part. So let's have a look. Let's just go right to a graph here on, let's do the working example on page 48. Okay, so the first thing that I'm going to do is I'm going to graph my original graph. I'm going to use the points of my original graph. And then I'm going to take the square root of all the y values. Does that make sense? Okay, so I'm going to graph. It says given f of x equals 4x minus 3. So 4x minus 3 0, -3, right? What's my slope tell me to do?
Up 4.
Up 4,
Right one.
right 1 to here. Just like that. Everybody's okay with that so far?
Yep.
Alright, so let's take some coordinates from this guy. Okay, let's start down here, but -1. So if I shove -1 in there, that gives me -7. Do we agree?
Yep.
Into my original? -1, -7? Yeah. And then 0, -3, which was my intercept. And then 1 and 1. 2 and
9.
5. 3 and
8. No. 9. 9.
3 times 4.
5.
Subtract 3.
Yeah. 5.
Okay. So there's my original graph, right? Okay. So they want you to take the square root of that graph. Now there's one very unique thing that happens on this graph that we do have to discuss, but we're going to wait just 1 second for it. All right, so let's graph. I want the square roots of them. Well, what's the square root of -7?
Root of -7. Or negative root of 7.
Square root of -7 is what? What's the square root of -4?
The original square root.
Why?
Because it's a negative digit.
Exactly. So what's the square root of -7? Pardon me?
Nothing.
There isn't one. Can't take the square root of a negative number.
Right.
Right? Grade 12, pre-calculus. Top of the top. Can't take the square root of a negative number. Great. Okay. So what's the first number I can actually take the square root of?
1.
No. What's the square root of 0?
0.
0. So, don't write this down yet. Here's your first value. Your first value is whatever that x-intercept is, because the square root of it is still 0. All right? The next one. What is the square root of 1?
1.
1.
It's 1. So 1 and 1 is on that graph. What do we call it when it's on the original and the new graph? Invariant point. Okay? If it stays the same, it's an invariant point. All right. Square root of 9 then is
3.
So I come all the way out here, and then it goes like this. Okay, so now I have my square root looking graph. Here's the catch that you have to remember at all times. All right? What is the square root of a quarter?
Half.
It's a half. What is the square root of 1/9? Square root of
It's
9.
1/3.
Yes. Square root of 1/16.
1/4.
Okay. What do you notice about the value that I'm square rooting and the value that I get?
Square the bottom. Where the bottom?
Yeah,
number?
or what do you notice about the two values? So I asked you what the square root of a quarter was, and you told me it was a half, right?
Yeah.
And the square root of a 9, and you told me it was a third, and the square root of 1/16 gave me the square root of a quarter, correct?
Yeah.
What do you notice about the value that I ended up with compared to the value I started with?
It's larger than
Yes.
that.
Yes, it is. Now, when I take the square root of a whole number, it always becomes smaller. Do you agree with me?
Yeah.
But when I take the square root of a fraction, it always becomes larger. Do you understand what I'm saying?
Yeah.
Okay? Why is that important? Because between 0 and 1, the square root graph actually goes larger and then goes this way. You have to remember that the graph goes on like a little curve larger than the original line between 0 and 1. Okay? That's important. That is a half a mark on an exam if you don't show that little bit above the line. Okay? You get that? And it only occurs in the square root of a graph. All right? Is everybody okay with that so far?
Mhm.
There's what the square root of this is. That's the square root of the original graph, the red line. Okay? So that'll be tomorrow. I'll work on that again tomorrow. All right? So some of you have to finish yesterday's test, and you can look at 2.1 today. Okay? And those of you that finish